Hello everyone, thank you for joining Rangerfall's webcast, Build Security In, Fix and Remediate Security, License and Architectural Risk Early in Your SDLC Process. Here to facilitate the discussion this afternoon are our partners from Sonotype, Nick Coombs and Ryan Sheldrake. As mentioned earlier, please write any questions you may have in the chat box or use the question function in your GoToWebinar control panel and they'll be answered at the end. I'll now pass it over to Nick.
Thanks, Priyanka, and thank you for inviting us to this second in a series of Build Security In. So today we're going to look at how you can fix and remediate security license and architectural risks early in your SDLC process. So we at Sonotype partner with Ranger4. Ranger4 our go-to partner in the UK. So thanks again for inviting us. So last time we showed how we could create a bill of materials to show you what open source libraries were inside your application, whether those libraries conform to your policy or not, whether they had any license issues and what all the licenses were for all those libraries, and also what the known security issues were with those libraries that were inside your application. So today we'll, just to set the scene, just give a little bit of background for 5 minutes, and then we're going to switch over to Ryan's environment, where we'll show you a live demonstration of how you can actually fix and remediate, which to us is the important thing. You know, everyone has vulnerabilities at some stage inside their applications, and the important thing is to be able to fix and remediate them as quickly as possible, so you have applications that are in production that are as clean as they can be. So just looking back to modern software development, today 10% of an application is written in source code, so typically your business logic. About 90% of a typical application is assembled from precompiled libraries, third-party libraries, or what we found is a lot of that is made up of open source libraries. Why open source? Well, it's quick and easy to develop functionally rich applications very, very quickly at agile speeds, but at very low cost, because you're just including those libraries inside your application. How do we know these types of things? Well, we at Sonotype run the Maven Central repository, which is the go-to marketplace for people to acquire their open source libraries today. There's about 1.56 million unique libraries there. Last year we had 31 billion download requests, and it's used by over 100,000 organizations. But because we run the central repository, it gives us a real unique insight into the ecosystem. Today there are 6.1% of those libraries that have known security vulnerabilities. Doesn't sound an awful lot, but that's about 90,000, which is up from about 60,000 last year. And also, there's over 200,000 libraries with restrictive license covenants. So that's the AGPL copyleft type licenses, where if you include those in your application and you host or distribute, well, you might have to give your software away, and that's something that people just don't want to do. We've done some research recently, and we found that typical application has 106 open source libraries inside it. So it's quite a complex ecosystem. And we've seen this with things such as Bouncy Castle or HTTP clients, and also struts from a few years ago. Bouncy Castle is a cryptographic library, so it's for people who security is really, really important to them. And this went and had an exploitability of 10, which is used in the CVSS scale, so it's 0 to 10, 0 being fine, but 10 being you're fully exploitable. Putting some context around that, so Heartbleed was a 5. So this is, if you've got this in your application, you can get owned more or less immediately. But since then, over 11,000 organizations carry on downloading it. And same for HTTP client, and same for struts. And it's not because people want to use bad libraries per se. It's just it's really difficult to understand these things. We've done some other research. This is across 25,000 libraries, so statistically pretty good analysis. And as we can see that the typical application has libraries that might be 1 or 2 years old, or maybe 8, 9, 10, 11 years old. The newer libraries have less than 5% known vulnerabilities. But as we start looking at some of the older libraries, you know what? There's 10, 11, 12% of those libraries have known vulnerabilities. But the chart for me that's really, really interesting is the right-hand chart. So we can see that of those libraries in your applications, or in those 25,000 applications, there's the libraries that are 8, 9, 10, 11 years old, and we can see that there's some significant percentages of those which are on the latest version. So what that means is there's a higher probability as your library ages that there'll be a security vulnerability, and there's a higher probability that you're on the latest version. So if you have a vulnerability, there's nowhere to go. So it's something really important to manage this risk around security, architecturally as well because of the age, and also obviously license because you don't want to give your software away. This is a chart from IBM. So IBM say that actually it's 100 times more costly to fix a problem when it's in maintenance mode as to when it is at the start of the process. Gartner, I'd say it's 30 times more expensive to fix in production than in development. Certainly it's at least an order of magnitude more expensive. And we're starting to see people such as OWASP actually point out, this is OWASP A9 in their top 10 of vulnerabilities, that look at components, look at binary libraries, look at open source, and just don't use it when it's got known vulnerabilities. We see people such as ISO, actually the 2015 version of ISO 27001, A1421 calls out for secure development policies. And we saw this yesterday. So this is an announcement in Register from Lord Blunkett. So very much, if you're selling to UK government, you might have to actually pass the Cyber Essentials test. And what that says is that you've got to make sure that when the manufacturer of the software updates their software, that you install it as soon as possible. And if there's security updates, just do it really. And I think it's not going to be long before we see this happening, that people who are using open source libraries in their applications have to ensure that any security vulnerabilities are fixed immediately. And also, you've got to know where it comes from as well. It's got to come from a trusted source. Can you imagine if we built cars the same way we built software? So we didn't know what's inside them. We didn't know what the quality, what the parts were. It's a high-performance car. Does it have high-performance brakes? We just wouldn't buy cars. So there's a fresh approach. Let's identify those risks early in the process, early in the software development lifecycle process. Automate policies because it's a very complex ecosystem. So humans just can't manage that. And continuously monitor for new risks because what's good today might be bad tomorrow. So here's a traditional environment. So we have developers create some code. They might ingest open source from places like Maven Central, may store it in a repository such as Nexus. Then you have a CI build stage, so we might build the application or some proprietary libraries, and eventually we'll build the app so we can use our continuous deployment tools to deploy it into our data center. This is a typical software development environment. So where does Nexus Lifecycle fit? So Nexus Lifecycle is a combination of the IQ server, which is the brains, and various plugins to the software development lifecycle, and we'll see in a moment, literally in less than a minute, of how the IDE affects that, so we can fix and remediate. But this connects to our hosted metadata service, where we have a research team researching on vulnerabilities, so that we're always up to date. You need to create your policy, which might be around architecture or security or license, and those rules are codified. Once they're codified in the system, we have a product called Firewall, which stops you ingesting open source libraries from places such as Maven Central or from NuGet or from NPM. So stop ingesting those libraries that break your rules. Sort of makes sense, doesn't it? Then inside the developer's IDE, let the developer see what open source is inside their application that they're building that initial stage, and let them see whether there's any policies that are infringed, whether there's any known security vulnerabilities, so they can fix and remediate it very, very early in that process. And then we can enforce those rules inside the CI process, so that what we want to do is to stop applications being built and ready to go into production that have known vulnerabilities. Then obviously we need to manage this holistically across all the applications within an organization and provide information back to trend and report on that. Then link out with things such as SonarQube, so static analysis, link out with things like Jira to manage your workflow and backlog around the organization. And then obviously, like all good DevOps tools, integrate with REST APIs so that this can be managed externally programmatically. But let's show you some of this technology. Let me pass over to Ryan, who's one of our solution architects, and let's show you this in real time. Oh, that's great.
Everybody, it's Ryan Sheldrake. Hopefully you can see my screen now. So we've already covered the bill of materials in a previous session. So this is about shifting left, so the developer has got accurate, actionable information at their fingertips. So what I'll do from the bill of materials is I'll jump over into an IDE. So this is IntelliJ, and we also plug directly into Eclipse, two very common IDEs. They're used across many market sectors. So there's a common look and feel to the plugin. It's a standard installation of a plugin. So in Eclipse, you can just go to install new software and download it, subject to you having a valid license to be able to do so. And then you have a pane that becomes available in the standard form down towards the bottom of your development environment. So I'll concentrate on Eclipse here, but the look and feel is exactly the same across the two. So I've got a couple of projects in my IDE, Eclipse here, and you can see that I've got Ponder XML with some dependencies that bringing in open source that can either be directly from Maven Central or via a Nexus or other proxy repository. So what happens within the Nexus Lifecycle plugin is that the POMs of the various projects are read, and all of the components that would be included in those projects are listed down in this middle central section here. This includes both declared and transitive dependencies. You can see that some in the list are in darker font and others are slightly grayed out. So those in the darker font are declared dependencies, and then you've got say iText 114 here is actually a transitive dependency that's been brought in because one of the declared dependencies requires this functionality. So we can see that we've got a scale here that runs from red through amber and then through lighter blue. So I've got this at the moment sorted in severity order. So I've got my most severe threats, which are evaluated against the policies which are defined within IQ server. So policies such as license bans, high security, and then we've got some architectural quality policies here. So say that it's older than 5 years, you can start to set policies that if a component actually breaches that condition, that will be reported directly in the IDE within this color scheme. So as a developer, I would start to look at my applications. I've actually got 3 being scanned here with 104 components. I can see that I've got some high risk or vulnerability or license exposures within my applications, so I could start to work through this list in a targeted manner. So I've got Commons Collections 321 within one of my applications, And we can see over here in the right pane that we get some immediate information available. So we got that this is actually quite an old component, as Nick says. It tends to be that the older components have had more eyes on them, so their vulnerabilities are found as things age. And we can see that we've got some fairly high. This is again a 0 to 10, the CVSS scale. This is a 9 out of 10. And we can see that we've got 2 policy breaches for the 3.2.1 version of Commons collections that's within my application. We can see that this is an exact match. So this means that the hash of this is exactly the same as a canonical version known, in this case, in Maven Central. What we can see over to the right-hand side is the slider. So we've got the current version that's within the application here, and we've got 3 sections within this. And the top one's the popularity, so how popular this particular version of this component was when being downloaded from the central repository. We've got the license risk, and then we've got the security alerts throughout the various releases of this component. We can see also that there are newer versions available here. So this particular component actually went vulnerable in 2015, having been very good for 7 years or so. Then there were some very rapid patches put out there, one by Atlassian and one by Red Hat. So if I was the developer, I could start to look and see if there are any security vulnerabilities in the newer version. Then we can see 3.2.2 was released. So if I click on that, that immediately then goes and reevaluates against the same policy and says whether the newer version has got any vulnerabilities or license exposures associated with it. And you can see here, when we reevaluate against 3.2.2, that becomes not applicable. But just back to what's actually in the application at the moment. If you want some more details on that, directly within the IDE again, I can hit the View Details button, and we can see which policies that have been breached within the IQ server. We can see that this has got a high security threat of 9, so it's been categorized as high within my policy. And we can also see that it's very old because it's 8 years, 5 months, and 7 days old. Further down to the bottom, we can actually see a little bit of information and insight as to what that vulnerability is. And we can see that this has been categorized by Sonotype's data team. This has not actually got a CVE reference as yet. And we can see that this is actually an arbitrary code execution vulnerability. So quite severe indeed if somebody can run arbitrary code within your systems via this vulnerability in your application. So if I was the developer, I may think I want to move to 3.2.2. Within Eclipse, you can click on the desired release number 3.2.2, and I can hit migrate within there. What that does is that will go and get the pom.xml for that project, and it will automatically go and update to the selected version. So at this point, if I was to click finish and then rebuild my application, I would have immediately remediated the vulnerability that's associated with Commons 3.2.1. That was done in real time, so that avoids going forwards into, catching it as part of the build or after a lengthy or costly test cycle run. It gives real actionable quality information directly to developers to make that choice based on the information and data that we hold centrally. We can also see within my list of components that we've got some transitive dependencies. So I've got iText 114 here. So I didn't declare that I wanted to bring that into my application. That was brought in as a second, third, fourth, and so on, a dependency of a dependency of a dependency potentially. If I click on that, we can get further information. We can see that this is actually not got any security threats associated with it. However, in the license risk, we can actually see that this is actually not, this particular version at 1.1.4 has got no declared licenses. But because we can go off and get the source code and look in the headers of that, we can actually see what the observed license and then the effective license is. of that component. So we can see that this is actually a GPL exposure. If you actually took it at face value, there's actually no license declared. And we can also, if we look for newer components, this is quite an interesting one, that if we look towards the most popular, that we've still got quite a high threat. That's because they're only declaring MPL 1.1, and there are many licenses associated with this particular source code of this component. And the very latest is actually an AGPL license. So as Nick said previously, that may mean that if this is included within your application and that's distributed, you may have to then distribute the entire application code. Now, the remediation for this is that you've got to buy a commercial license to be able to use iText within your application. But without this particular plugin, I may not have even known that the component was there, and I would have been very unlikely to be able to see exactly what I was exposed to as far as that being a transitive dependency. Nick, do you want to add anything onto that?
I think that just shows that it's really important to manage the risk, because if something is a transitive dependency, you might not know it's inside your application, and we quite often see that certainly 2, 3, 4, 5 levels down, if you're trying to do this manually to understand it, you're just not going to find those things. And you know what? Yeah. If you've got an AGPL license inside your code, that's the last thing you want to do. If you're hosting or distributing, because giving your code away, it's never a good thing.
Absolutely. Okay, I'll hand over back to yourself, Nick.
Yeah, no, thank you, Ryan. If you want to pass the presenter.
I will.
So thanks, Ryan. So just finishing off. So the business case for building security in. If we can shift left, mitigate our risks at the start of your development process. IBM says 100 times, Gartner says 30 times. It's a lot lower cost to fix and remediate problems in development. And you know what? Also, if you wait until you're just about to deploy your application, you get unnecessarily delays on actually going live. Manual processes, we absolutely believe don't work, but don't take our word for it. This is from some of our customers. We've seen people take up to half a day per open source library just to understand what the risk is. And on average, if you've got 106 open source libraries in your application, which our research has shown us, then that's potentially 53 days. Average sprint is 20 days. You're just not going to be able to do it to the level of detail by which it requires. We've seen increased developer efficiency. So 8% came from a German insurance company. They believed that by using these types of, or this technology actually, that they could save every developer 30 minutes per day because they wouldn't have to use Google to go and try and find out information. We found Aetna, who have a few thousand developers, they made their developers 30% more effective with this technology. People don't get rid of FTEs. It means that you can actually release on time or release more applications, faster releases. It means you've got less unplanned work because you're fixing it early in your process, which gives us fewer break fixes when it comes to having an application in production that I've got to do an emergency fix because I've just found out it's vulnerable. So we believe that by shifting left, making yourself more efficient, you're going to get increased innovation in the organization, which can only lead to increased pounds, shillings, and pence onto your bottom line. And really, really important, better quality software, because that's what we're all trying to achieve. So that's what we believe the business case for building security in, shifting left, fix and remediate early in your development process. And as a follow-up from today, we'd like to offer to everyone who's come and to listen to us over the last 30 minutes a day's consultancy, free of charge, to come and assess up to 3 of your applications. We'll provide bill of materials reports, give you a real in-depth understanding of any vulnerabilities that are found, so that you can actually go away and come up with a plan to remediate this, and take what might be vulnerabilities in your applications and fix those. So that's what we'd like to offer out to everyone who's on the call today. So at this, I'd like to say thank you for listening to me. I'm Nick Coombs from Sonotype and Ryan Sheldrake from Sonotype, and I'll hand back to Priyanka from our trusted partner, Ranger 4.
Thanks, Nick. So we do have a few questions. The first one is, what other languages beyond Java do you cover in Nexus Lifecycle?
Oh, that's a really good question. So obviously our background is Java, and very much our founder, Jason, invented Maven, which became that build tool of choice in that ecosystem. And obviously we run Maven Center on behalf of the community. So we're about to release, towards the end of the month, support for JavaScript, which, in my opinion, is going to be absolutely massive for us. We've seen a massive uptake in JavaScript, specifically also server-side JavaScript, with what's been going on at npm.org as well. So we're looking forward to that. Today we can also support people who are using the NuGet gallery, so for developing applications in C#. So we support that today. And our view into the future is to start supporting things such as Python, such as Ruby, so extending the support across the ecosystem to those, I suppose, languages that are using open source libraries at some quite big scale.
Great. Sounds good. And our next question is, does my code intellectual property get sent to Sonotype when performing application scans?
That sounds like a question for you, Ryan.
Yeah, thanks, Nick. So the answer is categorically not. So technically how the scan works is that SHA-1 hash is taken of the entire application and then of each component that's found within that application, and that and only that is then sent up to our hosted data service. So at no point is any proprietary intellectual code or executable code transmitted outside of any customer's own network. This is an on-network solution, and that fits very well with security-conscious organizations.
Okay. Great. And our last question is, can Lifecycle integrate into my delivery pipeline if I am not using Jenkins or Bamboo?
You want me to take that one, Nick?
Yeah, sounds like a nice detailed technical question for you, Ryan.
Yeah, so in effect, the answer is yes in the short form. So any build system that can invoke a Java command, so it can run a script of any description. So we provide a full command line interface that's just an executable jar that can then feed back return codes to either warn or fail at any stage, including the IDE, including in the continuous integration build phase. So yeah, anything that you can run a command line from, we can integrate into.
Great. Well, thank you. That's all for the questions today. So thanks, Nick, and thank you, Ryan, for joining us. A follow-up email will be sent to everyone with today's recording and slides. Thanks so much, everyone.
Bye-bye.
Bye.